Start working with exponential functions, and if you just recall for a second what an exponent is, 3 squared, that's an example of an exponent. 3 squared, of course, equals 9. Well, now we're going to have functions involving an exponent, and the exponent usually is going to have an x. So something like maybe 2 to the x. All right? It's a new member of our function family. We've been talking about our function family, and this is our newest member, and that is the exponential function. And just to start off easy, one of the things they're going to start with tonight, I'm going to start with an example, is they're going to say evaluate the function. All right? They're going to give you a function. I'll just use the same one. 2 to the x power. All right? And then they're going to say evaluate this function when x equals negative 2.1, let's say. So it's just like any other function. If I'm going to find f of negative 2.1, then I'm going to plug a negative 2.1 in for x. Of course, this is a calculator problem. All right, it's kind of hard for us to find a power of 2.1. So you can just go to your calculator, and I can put in 2 caret, I'm going to actually put this in parentheses just to be safe, negative 2.1. Hit enter, and you get a decimal answer. All right, so pretty easy. That's 0.233. And we use the TI-84 for that. All right. They may also give you some that maybe there's a little bit of algebra that we could do to do it on paper. One like this. Let's say that f of x was 3/5 to the 4x. And then let's say they want you to evaluate this when x equals 1/16. This one we can do, I think, pretty much on paper. Let's just kind of walk through it. So f of 1/16 is going to be 3/5 to the 4 times 1/16 power. Now, what we've reviewed this year with fractions is I can factor this thing out a little bit. I can put this over 1, and I can factor here. 4 divided by 4 is 1. 16 divided by 4 is 4. All right? And so now what I have is 3/5 to the 1/4 power. Okay? So I have a 4th root, essentially, of 3/5. And that would be a good place to finish that up with a calculator, okay? Because we're not going to be able to find, without a calculator, the 4th root of 3/5. So we would finish that with a calculator. I think you know how to do that on your own, all right? So, by definition, okay, it's good for us to just kind of write a definition. An exponential function is one where f of x equals a to the x. Okay? And what we're going to do now is I want us to kind of look at what happens. Let's kind of analyze and see what this function looks like. All right? And you're going to be asked to do this in homework, I believe. Graph by making a table. we're going to do the first one analytically, that means on paper or algebraically, and then after that you can use the graphing calculator. All right? Let's just start with our same function, f of x equals 2 to the x. And they're going to give you, I think in your book, a table that looks something like this. And I think they even maybe give you the values that they want you to use. Something like this. All right, so they give you a blank table and they want you to fill in the function values for those x values. All right, so I want to do this first one on paper, and then the next one we can kind of look at with the graphing calculator. So if I'm finding this one, the function value when x is negative 2, if I'm going to do f of negative 2, I'm going to find 2 to the negative 2 power. All right, and it's important to remember that a negative power goes in the denominator. So this is 1 over 2 squared. So that's 1/4. Our first function value is 1/4. The next one would be 2 to the negative 1. Which is going to be 1 over 2 to the first. The next function value will be 1/2. Then I need to find 2 to the 0 power. Oh, that's important. What's anything to the 0 power? 1. That's an important critical point for us for exponential functions, knowing that it always goes through 1 unless it's been transformed. Then I have 2 to the first, which will be 2. I have 2 to the second, which will be 4. And then I have 2 to the third, which is 8. And I think you can see that this thing is going to start growing very quickly. You know, what if we were to just come over to 5? Let's just do one more here, because I want you to get the idea of what's happening with an exponential function. This would be 2 to the 5th. So let's see, 8, 16, 32. So what's happening with this function, all right, when we look at the graph now, and we need to include a graph in our notes, is this function goes through 1 and then it takes off. And when you hear the phrase something is growing exponentially, they are referring to this exponential graph, okay? Because as I keep squaring and cubing and the power gets higher and higher, this thing keeps taking off. We know it goes through 1 here, all right? Everything else we don't need to plot. As we keep going this way, it keeps getting closer and closer to 0, but it never crosses. Actually, there is a horizontal asymptote right here at 0. It never crosses because I can't raise something to a power and make it negative. Okay? So this is the graph of 2 to the x. Okay? Now, as you remember, when we did transformations, things can be moved and they can be flipped around. And I want to talk about that for a minute. Let's now kind of use the graphing calculator. And let's see what would happen if my function was, actually I think this is number 2, isn't it? What would happen if my function was 2 to the negative x instead of just 2 to the x? All right? Like I told you, when you're doing the table problems tonight, it will be okay to use the graphing calculator to help you some. Now be cautious how you enter this. 2 caret, you need to put in parentheses negative x. Okay? And let's not go to the graph yet. Let's go to the table. And let's see, when did we start on that last one? About negative 2 or something? Negative 2, and we'll go to the table. And I think you will notice that things are kind of backwards, aren't they? Look what's happening. As I go in the negative direction, it's getting bigger, all right? And as I go in the positive x direction, it keeps getting smaller and smaller. So in other words, we've got a reflection on this one, okay? So if you want to just put, that there is a reflection, okay? If I look at my graph, you're going to see that it is reflected, okay? And it goes the opposite direction. So the graph of this one is a reflection. This is still 1, okay? That point is still 1. But this one is reflected across the y-axis. And those rules, you see how there was a negative inside the function? Remember when we said there's a negative inside, it gets reflected across the y-axis. When there's a negative outside, it's across the x-axis. So guess what? If I were to graph f of x equals negative 2 to the x, now notice that, make sure you understand what that's saying. You have to think negative 1 times 2 to the x when you see that function. All right, it's not negative 2 to a power. All right, it's like negative 1 times 2 to the x. If I look at the graph of this one, it's reflected across the x-axis, okay? And instead of going up like this, it's going to come down like this. All right, that's the graph of negative 2 to the x, and we could have confirmed that with the table. Okay, so like we said, notice that all of these have horizontal asymptotes at y equals 0. Okay, horizontal asymptote y equals 0, horizontal asymptote y equals 0. Now, what if there is a transformation? And you're going to see some of these tonight, where they say, okay, use f of x equals 2 to the x to sketch. All right? And they're going to give you something like this. Question A. G of x equals 2 to the x minus 3. So watch how easy this is if I remember my transformations. The graph of 2 to the x, remember I told you that critical point was the fact that it goes through 1. Here's the graph of 2 to the x. Okay, and this point right here is the important one. Look at this 2 to the x minus 3. Do you remember our transformations? Which way is that shifted? To the right 3 units. Okay? So all we have to do now is take this point right here and move it to the right 3 units. So this point comes over here, it's right there, and then the exponential function looks the same, it just goes through that point 3 units to the right. So there's the graph of 2 to the x minus 3. So where do you think the graph of 2 to the x plus 3 would go? To the left. If I wanted to do the graph of 2 to the x plus 3 power, then this point would come this way. This would be the graph, and I'm running out of room, of 2 to the x plus 3 power. Okay? Now, I know I'm cramming a lot on this one graph, but while we're here, we may as well go ahead and do another one. Let me get another pretty color. How about orange? What if I had 2 to the x minus 4? Now notice the minus 4 is not in the power. What's going to happen to that function? It's going to go down 4 units. Very good. So we're going to take this point and we're going to go down 1, 2, 3, 4, and that crossing point is going to be down here at negative 3. And so my function is going to look like this. Okay, this would be the graph of 2 to the x minus 4. Now, where is the horizontal asymptote now on this one? The horizontal asymptote is down here at negative 4. Okay, so when you have a shift down 4 units, the horizontal asymptote goes down 4 units. All right? So you're going to be dealing with some transformation questions tonight. And then they're also going to mention for the first time the letter E. The letter E is a lot like the letter pi. It has a numerical value. This is called the natural base. And E is approximately equal to 2.71828, and it kind of goes on a little bit after that. E has a numerical value just like pi does. So tonight, if they say use a calculator to find e to the negative 2, let's say, and we're actually going to be dealing with e as a function in our next day of notes. But let's just work with what e to the negative 2 means. Well, we're going to go to the graphing calculator, go to your main home screen, and if you look over here on the left-hand side, you will see ln. Right above ln is an e. Sorry, I needed to use a second ln. And when you do that, it will show e caret. Okay? And so then you just, our problem was e caret to the negative 2. You put in your negative 2, put your other parentheses, hit enter, and you get 0.135. So the E button is above, is the second function of ln. So the answer to this problem was 0.135. And we're going to stop there for today.